Today, we're disassembling the power head I took off of the 1959 12 horsepower Elgin Outboard that was completely seized up. This is the after-work garage. Welcome back. I'm going to start by removing the cylinder heads, and we'll get a good look at what's going on with regards to the completely seized up pistons in this engine. Alright, let's get this head off and see what it looks like inside. I was ready for way more of a struggle than that. Ooh. Gross. Okay, so let's see what we have here. So you can see these are the water jackets. So when water comes up through this pipe from the impeller, it's gonna come out. This housing has the impeller in it, and when the drive shaft spins, it pumps water with a rubber vaned impeller up through this pipe. It's gonna make its way up here into the engine, and it goes all the way through a gallery here. It goes all the way around the cylinders to keep them cool. So the head also has a water gallery in it, and it looks like there's a fair bit of corrosion. Alright, let's look at the bottom end. I just flipped it over and brought you a little closer. Heat and an impact driver is what I need here. Both of which are going to happen tomorrow. Hey, there we go. There's one. Okay, so when you have fasteners that are Loctited in like this and are difficult to get out, you're generally going to need to use some heat, because Loctite breaks down at a certain temperature, and then you're no longer going to be fighting both the stuck fastener and the Loctite. This is an impact driver. What it does is, as you hit it with a hammer on the back end, the top part pushes in and turns. So you're getting a turning motion. What that does is the blow of the hammer both shocks the fastener, sort of like an impact driver, like an impact gun, and keeps the bit forced down into the fastener while it's turning. You don't have to use those often, but when you need them, you need them. Let's get these other two out. By the way, if this engine hadn't been sitting so long, I would be a little worried about residual fuel and oil mixture in there that might catch on fire or give a little poof. Not the end of the world, but something to be aware of, certainly. bushing here that's keyed in. There's a little bit of a keyway. So it looks like this faceplate that we worked so hard to get off actually has the main bearing in it, as you can see. The needle's there. Interesting. Are you ready for this? I'm ready for this. Okay, maybe I'm not quite ready for this. Ta-da! Alright, let's look at what we have here. We have the block, obviously upside down. Crankshafts here, these are the counterweights. The main bearings for the crankshaft are going to be here, here, and the one we took off that sits inside this faceplate sort of deal here. Or inside this, I guess this would be the top main seal. Flywheel sits on here, keyed in. So this is the top of the motor. And then this end has the splining in it that has the drive shaft that goes down to the gearbox lower unit. I've loosened the rod end caps. So these are the end caps for the connecting rods that go and connect the piston, which is currently kind of they are seized up in the cylinder bores, to the journals on the crankshaft. And I've done this to pull out the crankshaft so I can work on the pistons. It looks like these have needle bearings in them, which are typical for connecting rods, not always on this end, but definitely on the wrist pin end in some engines. And they're a pain in the butt because they will go everywhere. So I've already taken these out. And as we can see, needle bearings sit in here and they form a roller bearing on the surface of on the journal and the connecting rod interior surface. So if I put this back together, I'll have to get new bearings anyways, but they do make a mess. One other thing I should mention, you don't want to put bearings on the wrong and rod caps on the wrong way, this way versus this way, because they're mated and fitted very precisely. In fact, they're fractured. So I'll show you that in a second, because they have to mate up perfectly with the other end. So here's a better picture of how those needle bearings sit in there. What you typically would do is stamp a mark on either end here. These are actually distinct enough that I can see the way that they went, and you can see it in the video also. So let's lift out the crankshaft. Crankshaft. Does not sound bad. I'm not sure it's supposed to be that loose, but it doesn't sound bad. There's no crunching. No crunching over here on this end either. Also easily replaceable, but interesting. All right. Pistons, rods, bunch of little things. So where the rods connect to the bottom side of the piston is called a wrist pin, and that's just a hollow metal piece that's generally either press fit in or held in by clips on the end, but it's a good sign to see that these are moving freely and don't look like they're in bad shape. So let's see if we can gently tap these pistons out with like a wooden dowel or something. Okay, I don't have a dowel, but I have a little piece of wood, and I'm going to try to tap these pistons out from the bottom here. one was moving. This one's stuck. Looks like it just came out of the factory. Alright, if you can see, there's a little pin right here. And that pin is a locating dowel for these rings so that the rings don't turn around the piston and get trapped in the exhaust or intake ports. Since the piston uncovers, opens and closes the exhaust ports and the intake ports, you don't want the edge of this ring springing out into one of those ports on either the exhaust side or the intake side. This side is pretty stuck. So piston rings should move around a little bit. There should be some, they shouldn't necessarily move around this way in a two-stroke engine, but they shouldn't be seized to the piston itself, like this ring seems to be completely. There we go. It's just crudded in there. Let's see if we can get the other one out. This has also been sitting with penetrating oil on this side for about 2 weeks now. It's kind of dried out and soaked in. I'm breaking my special tool. That is not healthy. So in this piston, I showed you these locating dowels that keep the rings from migrating into the intake and exhaust ports. And these rings are free, so without the compression of the cylinder walls, they are springy and spring up. This piston, which was significantly more difficult to get out, the rings are completely seized into the piston. In this case, it looks like they're just rusted, but as you can see, this is how it would be in the cylinder with the locating dowel right here. There's where the piston ring gap is. And these are stuck. This can happen when your engine overheats and rubs up and down inside the piston actually expands and rubs up and down inside the bore of the cylinder. It can also happen when you get oil built up, oil residues build up, and it gums the rings up into their grooves. But either way, you don't want this. You want the pistons to be able to expand, or piston rings to be able to expand against the walls of the cylinders. And then as gases, as the combustion gases come down and try to escape past the piston, they'll actually even help force the rings out farther to make a better seal. This is not looking good. Interesting though, because these rings do look like they're in relatively good shape still and are springy and have some texture on the outside of them still that's not scoring, like machining, they're grooved from the new machine grooves on the outside that run around. It looks like this engine was running and in pretty good shape when it was put away, and then was put away and never used, and moisture got in there and an animal got in there, as we saw in the leg, and built its nest, and everything just kind of rusted up. So this is a little clip that holds in the wrist pin. So if you're going to replace that, if you were to replace this piston head, you take the clips out, push the wrist pin out, and then put it into the new piston head. Let's talk about this crankshaft. It actually looks pretty clean. Okay, I know I just smeared oil and grease all over it, but these crankshaft journals do not look bad. They're not scored, they're not, nothing, not hardly anywhere on them. I'd say this motor is a candidate for rebuilding eventually, but it's going to take a little bit of work, and I'm going to have to buy some parts. Alright, as you can see, there's the exhaust and intake ports inside the cylinder. What you can't see very well is the rust color. This one looks okay, actually. This one looks less okay. Alright, so I opened up the garage and gave this thing a quick clean with some brake clean, and I'm going to take back some of what I said. It does not look amazing in there. There's quite a bit of rust inside the cylinders. It's hard to get a good shot of that. Let's see here. Not great. It's possible to be honed out with just a cylinder hone without having to bore it out and machine it, but we can certainly try that later. Looking at these pistons, this is the one that looked like it was in better shape. This is the one that was in worse shape and was really stuck in there. These would have to be replaced if we replaced the motor, or if we rebuilt the motor. Bearing surfaces in there aren't great. Bearing surfaces here, not the worst, but I wouldn't want it in my car. So I talked a little bit about rod end bearing caps. So when they're in the factory, they're made, the connecting rod here is made as one piece. This is still how they do it nowadays, or a very similar process. So they make this whole piece, they mill out the area that it's going to go around the bearing or journal, and then they cut this line into it with a saw. And that line, the purpose of it is to initiate a crack. So then they stick it on a mandrel, which is just a round metal thing that can expand, and then they open it up and it cracks this end off. So you can see this surface here is actually fractured. That's not a clean cut. And because of that, it goes back on exactly in one piece, rather than if it were to be sawed, there would be kerf that's the taken out. That's the width of the saw blade. And this way, no material's taken out. So when it goes back together, it lines up exactly. And as you can see, because it's actually fractured like that, you can't put it on the wrong way. You could try, but it's not advisable because it doesn't line up properly. And if you were try to put it on the wrong connecting rod end, it's immediately obvious that it won't match up either way. But since they can sometimes be a little close, if you have a bigger engine with more end caps, you're going to want to mark them. And the way to do that is with a stamp or a mark or a scratch that you can stamp into the end here and the side here. So back at the block here, and I'm going to keep taking this apart and show you the cooling passages and how the gas flows through two-stroke, since I don't think I'm going to be putting this back together anytime soon. So what we have here is the cooling passage for the exhaust. So the exhaust is about to exit out here. cooling water comes in and keeps this area cool. Let's pull this plate off and we'll be able to see the exhaust chamber. So this plate covers the exhaust and holds the cooling water jacket to keep everything cool in this side. So as we can see here, there's other cooling water passages to keep the cylinders cool as it's running, and then cooling water around the cylinders that comes up into the head. Alright, so this gives you a pretty good view of how as the piston comes down, it uncovers the exhaust ports and it's going to let out exhaust gases. And then as it comes back up again, it closes the exhaust port. So on this side we have the fuel pump. Now fuel pumps in two-strokes take advantage of the fact that the crankcase is pressurized to charge the air-fuel mixture into the cylinder. And the fuel pump takes advantage of this by having a hole, you can probably see it right there, that exposes a diaphragm in the pump to the positive and alternating positive and negative pressures in the crankcase area here. What that does is move the diaphragm up and down, and with one-way valves that allows it fuel to be pumped. So we'll take a look at that right now. So here you can see the one-way valve. This right here is going to be a relief or reed valve that when the diaphragm pushes up, fuel can come out this way, but it can't go back in. So here we can see the hole I was talking about that exposes this diaphragm to positive and negative pressure. It's old, but it's still in one piece. So when the piston's going up, there's negative pressure here and it sucks this diaphragm down, and that's going to suck fuel in from the fuel tank in here. And then when the piston comes back down, it can't come back here because of this reed valve. So then it goes, this diaphragm's then pushed up this way and it comes out here. And when it comes out here, it gets pumped to the carburetor bowl. This took a really long time to get the gasket material even as much as off as I got, but it's a connection between these two crankcases, and what the purpose of that is, I don't know. I'm gonna have to get back to you. It does look like there's little, almost jets down in these two holes. So I'll find out what that's for, and I'm interested to know. Now this is just a plate that directs the pressurized air-fuel mixture in the crankcase up into the intake ports of the cylinders. Well, there we go. We've pretty much disassembled the entire power head. As you saw, there were some good points and some not so good points. And given the condition of this motor, I think I'm going to set it aside for right now. It could potentially serve as a parts motor later, or more likely be a fun project down the line getting it back and running again. But I have enough projects on my plate right now that I think I'm going to move on to those. And for the time being, we got a good look at how an older two-stroke engine looks inside and how one looks that's been sitting a long time. So thanks for watching, and I will catch you next time on the Afterwork Garage.